Hello children, welcome to channel Sube. Children, today I am going to discuss question number 11 from the MCQ part of 2022-23 Physics New Syllabus paper. A uniform electric field of intensity 200 volt per meter is applied in between a pair of parallel metallic plates. What should be the separation between the plates in order to produce a potential difference of 10 volt? First one 20 millimeter, 30 millimeter, 50 millimeter, 20 millimeter, 20 meter, 30 meter. Children, this question is not a difficult one. So let us suppose that this is the two plates, and we have to give a potential difference using a battery like this. So the potential difference is 10 volt. V equals, say delta V equals 10 volts. So the distance, the separation, say delta x. So that is what they ask. The field intensity from positive plate to negative plate, like this. It is 200 volts per meter. This is E vector here. So negative charges. So we know the equation field intensity equals minus delta V divided by delta x. Sometimes we write it like this, E equals minus dV by dx. Both are same, you can use whatever you like. So they have given E as 200. The minus sign we can neglect, it is not necessary here. So delta V is 10 volt, it is given. So delta x we don't know. So isolate delta x, then 10 divided by 200, 1 0 cancel, then 0.5 divided by 10. Here what we have, 1 divided by 20, so you can divide by 2, denominator and numerator both, then we get this one. So 0.05 meter, that means 5 centimeter. Answers are given in meter and millimeter. So this one is 50 millimeter. That means the third one is the answer. So let's check the answer sheet. Question number 11. 11. Answer is 3. So correct. Children, here is our target question number 1. So try to solve this. Post the video on your own. Do it honestly. So I think you have chosen the answer, you have finished. So I am going to solve it. So as previously, the plates have 50 volts in between the plates, that is delta V. So delta x we have to find out, the distance between plates. The field intensity is given as 500 volts per meter. So the equation is same, dV by dx. So neglect the negative sign. So 50 it is given. Delta x we don't know. Capital E is this one, 500. So delta x equals 50 divided by 500. So 1 0 cancel, then 1 over 10, 0.1 meter. That means in millimeter, 100 millimeter, because there are 1000 millimeter to 1 meter. So here 1/10 of a meter, so that is 100 millimeter, or otherwise 0.1 millimeter is 100 millimeter. So the answer is this one, first one. Children, here is our target question number 2. Now try to solve it. Pause the video first. I think you have done. So now I am going to solve it. So the sketch, let us draw like this. The voltage is 50. Delta V is given. Delta X is given. The separation is 500 millimeter. 500 millimeter is 0.5 meter, because there are 1000 millimeters to 1 meter. So here 500 millimeter, that means half meter. Half meter means 0.5 meter. So positive ions here, because the positive side of the battery is this one. So the field intensity is from positive to negative, like this. So what they ask is E. So vector E equals minus delta V divided by delta X. So this one is delta X. Then minus sign we can neglect. 50 divided by 0.5, that means 500 divided by 5, that means 100 volt per meter. This one. Children, here is your target question number 3. Try to solve it. Pause the video. So children, now I am going to do it. So let us draw the sketch. 10 volt is given. Delta V is 10. Delta X is 500 millimeters, means 0.5 meters, because there are 1000 millimeter to a meter. The charge is given Q 3.2 coulomb. The force is what they want us to find, the force F, because they are positive and negative, the charges on the plate, so they attract each other, therefore there will be a force. So that force we have to find out. So if we released the second plate to move towards the first one, keeping the first one at rest, attached to a fixed support, then the second one will move towards the first one. Suppose the first one is not moving, it is fixed to a rigid supporter. So the force equals, let us write like this: energy, it has a energy, this plates has a certain amount of energy. Suppose this one is a condenser, then the energy is half time Q times V. Half QV, you know, the electrostatic energy is half time Q times V. So that energy is converted into this is a potential energy, it is converted into kinetic energy, and work done, if this force is moved a distance of delta x, so work is F times delta x. So these two must be equal because this energy is used to do this work. You know, work is the force times the distance. Distance is delta x. So after moving, the plates are at the same place like this. So delta x is 0. The separation is 0. So what happens? These positive charges and negative charges combine together and neutralize. So we can equate, therefore, first equation equals second equation. So half time, no, let us write to the left side, F delta x equals half times QV. So what we need is F, so let's isolate it, divided by delta x. So half times Q is given 3.2 coulomb, voltage is 10 here, delta x is 0.5. So here 2 times 0.5 is 1, so we don't have to write it. 3.2 times 10 is 32. So this is the final answer. The force, the average force is this one, 32 Newton. So the fifth one is the answer. Children, here is our next target question, question number 4. So try to solve it on your own, honestly, without watching how I solve it. Pause the video first. Now we start. So I think you have chosen the correct answer. Therefore now I am going to solve this. The voltage is 10, that is delta V. Delta x is 500 millimeters, that means 0.5 meter. Then what they have given is capacitance C, that is 0.32 farads. So what they ask is the force. So since there are positive ions here, negative ions here, therefore there will be a force attraction between these. There is a attraction between these plates. The plates, this plate is attracted by the first one, or first one is attracted by the second one. If one is fixed stationary, the other will move to the first one due to the attraction force, because they are opposite in charge, positive and negative. Then the same equation, the work done is when this charged plate is moving, it works, there is a work done, so that is equal to F times delta x. Then energy of the capacitance, the energy of the capacitor, half times q times v. So when these plates are together, there's no energy because all the ions are combined together and neutralized each. So here no energy. Then what happens to this energy? It is used to do this work. So therefore we can equate W equals E. Then F times delta X equals half times Q V, but we don't know Q. But we know Q equals CV. So C is given 0.32 farad times voltage is 10. So here Q is 3.2. So we can substitute it here. Delta X is 0.5 meter. Half times this one 3.2 times again 10. So F equals half times 0.5 then 32. 3.2 times 10 is 32. This half is here 10. This 0.5 came here. So these two becomes 1. So we don't have to write it. Then 32 Newton. This is the answer. So this one, the fifth one is the answer. So to solve this, you should know this equation and also this equation and also this equation. We used 3 equations. So children, now I am going to wind up the video. Let us see what we have done so far. We discussed this original question from the exam department, and I discussed this first target question and this second target question and this third target question and also this fourth target question. So I think you are happy. Then you have to make me happy too. You know how to do it by subscribing my channel, only if you haven't still subscribed. And also you can share my link among your friends and also press the bell icon and also press the thumb up icon. Then see you tomorrow at 6 o'clock children. Goodbye.